everyone, I'm Katie from Hackster. Welcome to the Image Detection with M5 Stack UnitV2 webinar. We've got Jimmy and Han here with us today to share more about M5 Stack's newest high-performance AI image recognition camera, UnitV2. So a little bit about our presenters today. Jimmy is the CEO and founder of M5 Stack. He's an experienced engineer who, through the years of creating software and hardware, saw gaps in the market. So in 2016, he began designing and creating a series of 5x5 centimeter module stackable prototypes to fill the gap between a development board and an end product for engineers like himself. Han is a senior engineer at M5 Stack. His work over the past few years has focused on developing training for M5 Stack's AI module training service called vTraining and on UnitV2 hardware design. So today we're going to have 45 minutes of a presentation and a demo, and then the last 15 minutes we'll have open for Q&A. So if you do have questions during the presentation, there's a Q&A button at the bottom of your screen. You can use that to type in your questions to us, and Han and Jimmy will answer as many of those questions as they can before the end of the session is up. So thanks again for joining us, and I'm going to let Jimmy get us started.
Hello everyone. I'm Jimmy Light, and I am the founder of M5 Stack. There might be some people who don't know what the M5 Stack is. Let me introduce something, why it called M5 Stack. And the M is for the modular, and the 5 is the size of the 5 centimeters by 5 centimeters. And Stack is for a set of stackable product systems. This is the origin of our complete name. And 5 years ago, I was still a product designer and had finished more than 100 product projects. But every time I need to design the hardware, software, structure, and assembly of the whole products. And from beginning to the end, I especially want to have a ready-made development tools that can help me achieve rapid product localization. Later, I got the inspirations that we could make all kinds of the function modules in advance. Users can choose combinations according to their needs. After stacking, they get the products. Later, we follow this concept and start to build the M5 ecosystem. And at present, okay, here is our family. And we have more than 300 SKUs. There were some main series here. The first is the 5x5 stack classic series, which is composed to the main controller, communication modules, and the function modules, and the extension bases. Each device has the same M5 bus, so they can stacking up. Now we have provide the servers of the core controller, more than 20 communication module, more than 20 function modules, and more than 10 basics modules, which can be basically meet the needs of the many situations. The following is the stick series. It's about the size of the USB flash disk, but it contains CPU, Wi-Fi, Bluetooth, battery, screen, IMU, buzzer, microphone, and the extension interface. There are many applications that can use it directly. Also, you can insert a hack to implement different functions, such as detecting the environment and measuring the heartbeat, and so on. Later, we launched the Apton series, which focus on the cost effectiveness. We simplify the main control as much as possible just for the best prices at $7. It can be achieved by expanding different application bases. A variety of the functional application, including a QR code scanner, motor driver, and DTU, PoE, and the AC socket, and so on. Last but not least is our camera series, which focus on For example, this timer can is a low power consumption solution with the battery and the Wi-Fi. Let's put it this way. Usually the webcam is sleeping. It will be resuming to work by setting the timer and then return to sleep. The battery can be used more than 1,000 times in this way. Okay, let's move to the AI camera. Before this one, UnitV2, and we have the Stick V and the Unit V, and they both are the K210 solution. So we can use it for some AI operation locally, such as the face and the object recognition, and so on. And this UnitV2 is the main role of today. It has more feature and better performance than the first generations. Our engineer Han will introduce it later. There is also a series of the low power consumption in screens. They are conserved power and for the scheduled time to wake up. Okay, this is the unit series, and including some sensor communication modules and the data transfer and some actuator. For example, the relay. Okay, that is pretty much for our product catalog. We are targeting to helping everyone legalize the products as much as possible. You can subscribe to our social media and feel free to contrast us. Okay, this is the M5 story. Okay, it's in the next.
So after like a short introduction from Jimmy about like the history of M5 stack, so let's focus more about like today's stuff, the M5 UnitV2. So V stands for vision. So this is the second generation of M5 stack's vision series of AI camera modules. So you're kind of be worrying about, you can be like thinking about like what happens to the first generation. So let's first look back and see what we have did and what about it. So, oh, okay, great. So this is the first. This is the first generation of the M5 AI camera. So this is our first generation of the M5 vision camera. It uses ChemDry's K210 as a core processor. This is a pretty powerful AI dedicated accelerator. It can go up to like 300 gigaops per second. The ops per second stands for operation per second. It means like how many additions and multiplications it can do in a second. So 300 giga of ops is a lot. And it's pretty high power, and its power efficiency is pretty high. It takes about like 1 to 2 watts and it doesn't even need a cooling. And it works so well. And it's somehow cheap. It's $4. I mean, it's relatively expensive, but we're comparing to like the same product, like one from NVIDIA, some Intel or NVIDIA, it's much, much cheaper. And the con of it is also pretty annoying. So it have like pretty poor quantization scheme. Quantization scheme is something that nowadays those dedicated AI accelerators are not good at it. So it works like this. Normally, when you get like a computer vision model, like those AI models, they're in the float form. Like you need to do like float operations, like 1.2 times 2.3 equals what. But doing float calculations is pretty hard. I mean, when you consider like doing 2 times 3 and 1.2 times like 9.9, the first one is much, much easier. So they think, okay, maybe we don't need that much accuracy and we can just let them use the integers to do computation. But since this chip was designed too earlier, even earlier than the release of the ResNet, its quantization scheme cannot fit today's algorithms, and it's a little bit outdated. It's still very powerful, but you have to design a network for the chip, which raises like a very high bar for the users. And also it has a pretty small memory. It has 6 megabytes of SRAM. It's super large when you're comparing to other microcontrollers, but for AI applications, that's just a little bit. Like Normal models would be like 20, 30 megabytes, and those mainstream models would be like a couple gigabytes. So 6 megabytes, not good at all. So that's our first try. We kind of like it, but we're not able to get pretty high accuracy on it. Like we designed our first version of the retraining, as the guy mentioned before. It works, but I mean, we train the models to like 99% of accuracy, but after quantization, I mean, to convert the model to the format that can run the chip, it dropped to like 30 or 40%. So I think we have to evolve it from it. And this is also one of our try. So this is M5 stack timer cam that Jimmy just invited before. It uses the ESP32 from Espressif. It's super cheap and it's super low power. I mean, it can sleep at like 2 or 3 microamps and wake up in like 1 or 2 seconds. You have a lot of powerful files. You have like accuracy, PWM, and super high speed UART. And everybody like ESP32. But the concept is also make it not very good because it's not very powerful. It only have like 240 megahertz CPU, and it had like 400 kilobytes of memory. You can run some tiny network on it, but still you have to design a network for it. And those tiny networks normally cannot produce enough accuracy. We want to do anything serious. So what we expected from like a good AI camera, we want it to be cheap, we want it to be super powerful, we want it to be low power for files and easy to use. But for the time being, it's pretty hard. So instead of focusing on like super high power, super high computation, but it requires users to be like really knowledge, even being like the domain expert, we're trying to make we're trying to make things that is work. Not too expensive, but for users, they're really easy to use. So this is our goal for our product. And this is what we end up with. We end up with something that can run Linux. It's easy to access. You can just use your computer's USB port or through Wi-Fi. And all those files are in Linux standard drivers. The camera is in Linux, is in like UVC standard. And the button is just like a file IO and etc. So everything's really easy to access. You can just copy paste the code from like GitHub or Stack Overflow, and it should run. And it's pretty safe. We do a lot of things to make sure that the device is safe, even to children. I mean, if they don't swallow it. And and maybe you can put some like pre-built program on it. We're going to show it later. And most of the hardware and software will be open source. So let's see a short video about the product. Okay, so after a quick recap about what's ability, let's see what this consists, what this construct of. Okay, so our main IC is from Sigmstar SSD202D. So this is an IC that meant not for AI application, but we think it's pretty. We think it pretty fit our use. It has dual core Cortex A7 running at 1.2 gigahertz. We actually boosted to 1.3 gigahertz. With Neon accelerator. So the Neon is what we are chasing for. So this is a highly parallel SIMD instruction extension that allow those UI AI applications to run like much faster than those CPUs who don't have Neon. So the chip also have 128 megabytes of system package DDR3 memory. Not much, but from our pros experience, it's good enough. It also have 512 megabytes of NAND Flash and a weird USB LAN on it. You're gonna know what it's for in later. So when you flip the board, and there's a 150 megahertz 2.4 gigahertz Wi-Fi on board. So we have Wi-Fi, and you can use Wi-Fi or USB to access the board. And there's also an SD card slot to allow you to use SD card to move in and move out data, and a little plug-in for the camera module. So the camera we're using is a GC2145. It's a 1080p camera. It provides much better resolution than our post products. It's not the best, but we think it's good enough. And aside from all those board designs, we have designed some interesting mounting plates that can either clip on the unit and mount on like a school ball style driver. It's a standard quarter inch bowl. I think it's a bowl. And or either we're going to provide a kit that you can install on any Lego compatible devices. So aside of this, you may think there's like some heat exhaust design on it. And we actually spend a lot of time in the thermal design of it. So there's actually a blower inside it. So the blower we're just gonna keep the chip cool and running at any time from like 0 degrees Celsius to like 60 degrees Celsius. Our initial design actually doesn't include a fan, and the whole device is like blowing hot. We think that is very dangerous. So instead of saving those money, we're saying, okay, we're just going to throw like a blower inside it, and we just want to keep the device safe and good. Also, there's not sure whether you can see it. So people are not able to access the fan directly. There's like a shield. Okay, we're going to see it later. So this is like a shield in front of the fan to prevent any obstacles getting inside. So next is about our system level design. This is one of our simplest board from the M5 stack ever. So we have SSD202 as our core controller. Sorry, it's 128 megabytes, not 256. You have 128 megabytes of DDR3 memory, and you use USB port to connect the camera through like a USB ISP chip, and through USB port to connect to the Wi-Fi. So we can talk about later. And there's also a 2150. It's 512 megabytes of NAND Flash and 128 megabytes of DDR3 memory. So it uses QSPI connector NAND Flash. We tested it's around like 40 to 50 megabytes of write speed, and use 100 megabytes of length connected to the chip. So we apply the computer. It actually emulates a network device, and it's not emulated. It's an actual Ethernet chip inside the machine. So this design will keep the machine really stable. So unlike those simulate one, you won't gonna experience any unstable or other scenarios. So it's pretty simple and straightforward. And since we have like a Wi-Fi on board and the LAN on board, our network design was like this. So we have the Wi-Fi was running in the AP plus STA mode, which means you can connect to a Wi-Fi through the WLAN 0 port, and you can also act as an AP an access point that you can plug the board into any power supply and use your computer wired or wirelessly to connect to your device. Okay, so that's a quick cap of what we can do. So let's start with some function demo. So this is our function demo. We're trying to make a rock, scissors, paper machine that can always win you by using the function inside our tiny video with the provided V functions. So I have to swap the video. Okay, wait a second. To turn off the mirroring. Okay, worked. Great. So this is our V2 camera. You can see you have like a glass covered screen, glass covered camera, and a Type-C USB port for connecting to the computer for debugging, and a Groove port that is cross-compatible with all M5 stack products. So let's start by connecting this device to the computer. Get a USB cable. Plug it. The plug-in. There's a white LED over here. It might be hard to see on the camera. Yes, it's a white LED on here and a red LED. When both LEDs go off, it means it's boot up and it's ready to run. The boot up speed is around 10 seconds, but loading all those large models actually takes time. So it takes about like 15 to 20 seconds when trying to enter the actual program. Okay, so let's. Hi, can you see my screen now?
Yes.
Okay, yeah, it works. Okay, great. So this is all the functions we provided with our board, and it does not require any like license or anything. It just open the box, you can use it, and the code will be open source lately. And we're just continue. We're gonna fill up more applications into our we call it V function. So let's just briefly go through. Let me pick up the demo plate. Hi, okay, let me switch the video. Yeah, things are working. Okay, so you can see this is a clip that showed in the video earlier that you can just clip your UnitV2 in, and it's ready to go. So just clip it in and remote it back, and you can see the plate over here. Okay, now I see. So the first function is pretty boring. It's streaming, it's camera streaming. But instead of you using the video, you can actually use this address or streaming to your own devices or your own web page. And we have code detection that detect the code, detect the quad code, and that detect the quad codes or the kind of binary code or through AI. Just wait a minute. Okay, got it. So you can detect code and decode it if you can decode it. And then we have the object recognition, the color tracking, the line tracker, and etc. If you're curious about what those functions are, you can just watch our video or played it earlier, but you can watch it later online. So let's just jump into our topic: how to make a rock, scissors, paper machine. So we're going to use this function called online classifier. So the online classifier is a tool that's going to train a network fully online, but not exactly train. We're going to explain how it works later. So let's restart it, and you can type in like what class you want. So first we want a class called background. Thus we can know whether do we put like a hand in here. We train. Okay, I have to check this one. Okay, we train it for multiple times to let you know like when there's nothing in the thing. Okay, then we add we call it paper. Select it, and we try to train. We try to train with my hands inside. Okay, and another one. We call it how to pronounce Caesar. Got it. We call it Caesar, and we we have like a scissor here. And then we have like the final one, it's called rack. We select it and we train our rack multiple times. And now we're ready to go. We can just save and run. So now it's the background. Here's the paper. Okay, here's the paper. I should put it higher. Yeah, maybe I need to, since it's only detect the thing in the box, it's sometimes not very well if it not high enough. Yeah, I think it's working. Okay, let's just stick with it. Okay, the scissor, and maybe I want to train the paper more. And how is it working? Scissor. It's not designed for recognition hand, so it works. It works before. Okay, let's click to rock. Yeah, it works. Okay, let's just stick with it. Okay, so during its recognition, it's gonna output those data. Those data are in the JSON format from the UART port on board. You can see the UART port when you flip it. So here's the UART port that you can extract data from it. It's just gonna directly stream out. And then how to use it. So we're gonna use our another product, we call it core. So this is a stand. So plug the core in, plug the core on the stand, and plug the cable in. I think it's in this side. Don't burn off my device. We have the grip cable, so don't use it. I just don't have it by my hand. Okay, great. Blinks, lights up. Flip it back, and I don't have a program inside, but we can just rewrite it. Press the button, and we can enter the UI flow menu. Switch mode. We'll switch to the internet mode. Reboot to let it work. Okay, it's just going to connect to the internet, and now I can use the flow here. And yeah, it's connected. Yep, it's working now. So now this terminal is already connected to our device, and what we need to do is we just need to receive the data and see how it works. So we're gonna try the blockly in our second demo, but let's start with Python first. And for the time, I'm just going to copy and paste out the code, and I'm trying to explain it. Okay, so we first need to import some basic libraries. So this is the basic MicroPython stuff. And we have like 4 images already built in, which are called background.jpg, rock.jpg, scissor.jpg, and paper.jpg, which you can see from here. I can already upload those because uploading is kind of slow. Okay. And then we start a UART communication with UART communication on the port. And we type in the how to win guide of it. So if we have scissor, if we recognize scissor, we wanna hand out the rack. And if we have the rack, we want to hand out the paper, and vice versa. If we say background, okay, that's the background. And then we receive the data from the UART, which is, since it's just JSON, we just load the JSON, and seems like we don't need to display it actually. And if it's a match, if there's a best match in the request, which means it's sent out like in this round. There's a best match here. We just need to read this number. And if there's if the request, the best match actually in the how to win guide, we just put the image on. So let's place the round. So when I place the round, the file just going to be pushed to the file pushed remotely to the device, and I think we're ready to go. Let me have a try. Okay. Yeah, it works. Is it frozen? Maybe I try something easier for it. Yeah, it works. Maybe I do it. We tested it earlier. It works perfectly. I mean, yeah, rock again, and tweezer. So the system works like this. Online classifier actually extract a tensor, actually runs an actual neural network, and the neural network gonna extract the. So this is like an input image. So you have the input image, and you're gonna throw the input. You're gonna throw a log along neural network, and you get a vector. So this 128 numbers are gonna describe what kind of object it's seeing. So by showing a different kind of object, we're gonna know like and if it is able to distinguish like different objects, it will give you different vectors. So by separating those vectors with like a clear line, for example, you have like one vector out, we know that if it's larger than 0.0, we know it's a Caesar. If it's like smaller than 0.0, 0.5, but larger than 0, we're gonna know it's a rock, something like this. But due to this system, we don't need to learn those all complex things. We just need to know how to write our program. So the program actually looks like this. So we have this M5 UnitV2 running all the visual application stuff, and we have this we have the standard driver that drives our image sensor. So we have the V function. The V function is actually this whole web. The web browser, the web server is actually running inside the V2, and all the processes down in the V2. It just transmit the image to the terminal to the web page. So there's a switch inside V functions. There's we have the feature extraction and compare, which is the online training we're using. We have other functions that require some resources. There's a switch in the resources. And if we need the feature extraction, it switch the feature extraction function. And it sends the output to the UART port, and UART port sends to the UI flow, which is a software that we designed to run in the core. Okay, so that's a pretty easy demo. I think it's, if we can redo it, it should be better. Let's try it. Let's try it again. See there? I think the formula is wrong. Yeah, it works pretty good. Okay, so let's continue. So aside from all those pre-built functions, we also have we also have something called Jupyter Notebook. So this is a function that we use to write Python codes. We use to write Python code interactively. We can enable it by we can just switch from those static pre-built functions and switch to the notebook. That we can just write any code we want just in one click. We just click the switch to notebook mode, press yes. And it's okay, refresh this page later. We'll wait a few seconds, and yeah, it works. So this is the Jupyter. So Jupyter Notebook is an interactive Python interface. It allows you to write the Python codes in a more beautiful way than the REPL. So we can start this notebook. This notebook is pre-built in all the M5 stack UnitV2 devices. So welcome. So unlike the previous devices like ESP32, the UnitV2 is running a full power Python 3.8. And you can use all those fancy features that you learn from the GitHub or GitHub or other place. And it supports all the new features of the Python 3.8. And aside from the full support of Python, all those I/O controls, including the LEDs and the UART, are supported by some really easy library. So for control the LED, you just need to write to the file, and you just tell to the system that I want to use this I/O and set a direction, and we can just output a value to it. So first, let's try to turn on the white LED. LED is on, and then okay, it's focus. And focus. Okay, and then we can just use a simple code to shine this LED. It's much easier when you're comparing using the Arduino that you have to struggle with all those C++ commands. And also the same with the UART communication, but since we don't have the device, so we're just going to have a C. So you basically just import the serial libraries, and you initiate a serial device with this device and the baud rate, and just going to write and read. Super easy and super fun. And then the next section is the camera, where we're having the full we're having the mostly full OpenCV inside. So you can just import a CV2. No, I don't want to take my picture. Let's take a picture of the camera. Okay, and it just take a camera. Oh, why? Yeah, it works this time. And if it shows successful, it means you have to get a frame, and we can just import matplotlib. Just the same as what you're doing on the PC. And we can just show the image. Yeah, got an image. But you see the color is a little bit weird because normally when you get the image from the OpenCV, it's in the BGR format. So you can use a color version, color space converter to convert into RGB and show it again. Yeah, it looks pretty good. And we also can convert it to black and gray if you want. So basically you have all the functions of the computer of the OpenCV2. You can use any OpenCV script you want. You want to do like shape matching. You can just use OpenCV to finish all the product. Not product. You can just use OpenCV to work on all the stuffs you learn from the internet. So this is basically like a HPC, SPC, SPC, but we just throw a lot of things inside to ease the development. So let's try something. Different. So we can just shut down this one. Shut down. Okay. So since this works as SBC single board computer, we can do a lot more things than just as a sensor. It can actually add like a host. So let's try a small MQTT broker sample program. So first we want to start the broker. It's super easy. You just run the broker with Popen and just throw in. And then we can use the Paho MQTT, which is just the Mosquito client, and we subscribe a message and connect and try to connect it. It shows 0. Yeah, so we successfully connect to the MQTT with just like less than 10 lines of code. Then just as I mentioned before, you can just access GPIO. You can just access the GPIO just using the open. There's no actual API required. You can read and write. So this GPIO actually links to the button. So if you read it, so you're going to read the status of the button. So if I didn't press it, it says 1. And if I press the button, it becomes to 0. So let's write a simple message program that when I press the button, it sends a message to another device. So let's use this M5 stack device as an example. So first, let's finish the program. So let's see. Okay, there's another one. So this is a press 1. When you read 0 from the button, it means you already pressed it. So let's send a message called press button pressed. And if there's 1, that means and after you press the button, if it becomes 1, that means you release the button. And when you release the button, let's send a message called released. So let's first test it with our MQTT box, which is an application for debugging MQTT communication. Where is it going? Yeah, I see it over here. We drag it here. So this is MQTT broker. You already connect to our device, and we can subscribe to everything. So this means subscribe to every topic. Subscribe it, we press the button, release, just work. So how can we communicate this device to our tiny M5 stick C? First, we're going to power it on and enter the UI flow as before. Okay, works. We just select the COM port. COM port 7, great. So the first thing is we want to connect this device to this device through the Wi-Fi. It's pretty easy. We just search for Wi-Fi. And no, it does not work from here. We have to select the Wi-Fi here. Okay. Network. We need to connect to the Wi-Fi. So when you get the M5V2, each M5V2 comes with its own identity, its own like pin number. So for mine, it is M5UV2 -7380. And the default password is 1234567 8. Okay. And then we try to connect to the Wi-Fi. We set up it. And we connect to the Wi-Fi. After connect to the Wi-Fi, we want to connect to our MQTT broker on the device. So let's connect to the MQTT broker. We just need to type in the server IP, which is. You can also use the UnitV2.py but sometimes there's compatibility issue. If it does not work, you just type in the server IP and just left everything. Okay, and let's start MQTT. So we also wanted to subscribe it because we want to receive message, don't we? So let's subscribe the button topic. And let's check the label here and rotate it 90 degrees. Where's the rotate? White is okay. Rotate 90 degrees. And we can set the label with the MQTT received. Okay, it's good to go. So when we execute the code, we can just press the button. It says press. I'm not sure you can see on the screen. Just press, release, press, release. Just this easy. So if you want to have some beeping sounds to notify us, we're just getting the beeping module. And we add a head here. We want to use the speaker module. Okay. And we select the speaker. We want to beep it. Quarter with, I like the middle C. Wrong? Okay, does not like it. Oh, yeah, I'm still there. Unplug it. Okay. Okay, works. So this time when I press the button, we're going to beep once time. We're going to beep once. Can you hear? Maybe it's a little bit too short. Okay, so you want to communicate from the device to the M5 UnitV2. How are we going to do it? So the easiest thing is that we just double press the button and we create a new event called was pressed. Just press again, we create another one and set another one to was released. And inside MQTT, we just need to publish the topic. We call it LED control message open. And another one, we call it, open and close. Great, just download it. So when we press this button, you can see from the MQTT box, you're gonna release, you're gonna send a message and gonna send a message. And on the other side, on the UnitV2 side, we just need to subscribe to the message. You need to stop it. I'm going to update the message event. Yeah, and start from the topic. And at this time, when we press the button, the lights goes off. It goes on, goes off. This is easy. You can just communicate all your device with your environment. So let's go back to the PowerPoint. So this is the power of the Jupyter Notebook with our UI flow environment. You can just write Python to control everything you want. And last topic is about the V-training. So this is our online AutoML system, which means you can select the pictures and you can just annotate downtime online, and you can just select the train and you can select which train mode you want to go. You want to either go with the like higher speed, lower accuracy, or you want to go with like lower speed, higher accuracy. And after it finished train, you can just preview a mode, which you can just upload image from our device or from the web, and you can just preview how the model are going to do like. And after all this process, you can just download the model into your UnitV2 and just run it and get a JSON output as we just shown. We think the service will be fully free, but we're still considering and we're developing. I think they're going to be ready in the earlier June. And I think that's all for today's introduction. And for M5 UnitV2 to be available from those following distributors and at those given times. Beginning the Beijing time at 5 o'clock in the afternoon, Japan at 6 o'clock afternoon, and sorry for those British guys, for those guys in the Europe, it's gonna start from like 10 o'clock in the morning. And sorry for United States guys, I'm gonna start from 4 o'clock in the morning. And there's a hackathon. So we also raised a hackathon with AWS in the next month. One of the prize will be this super funky, this super good looking or newest product with the cool AWS color. So please attend. And I think that's it. Let's go into the Q&A section.
Yeah, thanks, Han, for the demos and for sharing. The contest with AWS is, I think, coming up in the next month. And so we'll have more information on that later. We have about 3 questions in the question and answer section, if you guys want to take a look at that. And I think we've got about 9 more minutes, so we should be able to answer those.
Yeah, sure. So the first question is there HTTPS library? If you mean on the UnitV2, yes, it supports HTTPS. You can use the Flask. You can use other use Cure. Basically, it's just like a complete Linux computer. But I'm not sure whether you need to write your own key inside it. So you can just use as a general Linux computer, and it should work. Okay, and will this Jupyter Notes be available on the m5stack.com v2 site? We can upload it to there, but you will get those notes. You're getting those notes shipped with UnitV2, and we're going to also upload those notes to our website. And in addition to that, we're going to provide more notebooks along with our updates. Okay, what kind of hackathon is happening? What kind of them will there be? I think this will be later answered by Alan. So let's just wait a second. It's possible to preset a green box size and location. It's possible to create more than one green box in one screen. I will quote our software engineer. I think it's possible. We can do it in our later version. I think it's a good idea. But to be aware, like each green box actually we need to do like a full calculation. So the more you have, the slower you're going to be. Okay. So yeah, let's go to Alan answering about the hackathon stuff. Is Alan here?
In regards to the hackathon, actually, we are holding it with AWS based on the products we call tool for AWS, which is a touch screen M5 stack core and with a security element. You can one click to connect to the AWS cloud with all the functions. So the hackathon may be held on later this month and also just holding just by Hackster. Later on, there may generate one link for that. We may also just post it by our SMS. You can also check it on hackster.io for any news that. Yes, thank you.
Yeah, so it will definitely be posted on hackster.io, and more information about that will be provided in the next couple of weeks. There was also a question in the chat. Han, I don't know if you saw that from John.
Yeah, I just said, okay. So the first, I didn't see any performance figure of speed of AI processing because we're still working on, how to say, enhance the speed. I forget the word, sorry. So we're still working on the speed. So we're not releasing the actual figure for here. Will they be able to run model like MobileNet or YOLO? Actually, I can show you what models we're actually running. So you can just directly SSH inside and you can see all the files. So all the model files actually here. Okay, home M5 stack. STCK. Okay, in the payload session. So here's all the files here, and sadly, our pre-built are all in binary formats because we want to increase the speed to some. We want to increase the speed, so we use just use binary C++ to write it, and all the models are here. So for the detection demo you're seeing, we're actually using Nano Detect, which is something similar to MobileNet v2, but is something similar to YOLO v3, but is an anchor-free model. And for the object recognition and for the rock scissor one, you're seeing we're actually use a retrained ShuffleNet v2 model, which is similar to the MobileNet v2. What sort of inference speed could we expect at say 22? It depends on actual model you're running, and we're also working on the quantization. So if you're using MobileNet v2, I think it's about like, I think you can get 10 frames per second. And for YOLO, if you're just wanting the YOLO original version, it'll be pretty slow. But if you're trying something like YOLO v3 with like 0.5 for MobileNet v2, you can get about like 6 to 7 frames if you don't need to stream to the computer. To actually stream to computer takes a lot of computation power because you need to decompress the image and recompress it. What image size being processed there? I think it's 120 by 120 with ShuffleNet v2.0. Yeah. Can we run TensorFlow Lite directly on the UnitV2? I think you can, but TensorFlow Lite are not optimized for such devices. So they're more optimized for like higher end one. So you can run it, but the performance may not be as good as expected. So the inference engine we're using is called the NCN, which I can show you here. Let's call this. So this is a Chinese inference framework dedicated for those resources constrained devices. And it does a lot of optimizations for the CPU we're using, the CPU architecture we're using. I think that's it.
One
more have more questions above?
One more question, I think, in the Q&A.
Let me see. Do you have the sample node for V2 similar to demo in this event? Not fully understand the question. If you're asking like we're going to provide the demo we're doing today later, I think yes, but it's not a very good demo. So we're going to make it run much better, and we'll release as a sample program for users. Yes.
Great. Awesome.
Great.
All right, well, I think we are out of questions, and that's perfect because we're coming up at the end of our hour. So I just want to say thank you, Han and Jimmy, for your presentation today. Thank you, everyone, for joining us. We will be sending out the recording of this early next week in an email, so you'll have that available as well. So, oh, wait, one more question. How does the product differ from other similar in the market?
Actually, in brief, we don't see much similar product in the market. So we're the kind of product we're making is actually, we call it like intelligent camera. So it's basically how to say, it's a compact device that have the camera inside. So there's other company that make it like the Basler or the HK Vision, but they use it for like really intense, like for engineering, industrial using. So they have like really high power CPU, really high power camera, and really high price. So we want to make something that is easy to use, easy to access, and is cheap. So don't have something to compare. So if you have to compare, if you compare to other boards like Jetson, I think we're smaller, we're more compact, but we were trying to compare the performance. The Jetson actually is better because I mean the chip for the Jetson is bigger than our product actually. So yeah, so we're not meant to have like super high performance, but we're meant to have being compact and easy to use. I think that's our goal of this product. But actually, we're making something that is really, really powerful. But I think that released like after half of a year, like in 2022. So be prepared.
All right, great. Well, on that note, I want to thank you all for joining us, and I hope you have a great rest of your day, evening, morning, wherever you're located. Thanks again. Bye.
Bye.
Bye.